while I'm walking up here, so I just wanted to say a minute about how the origin of this paper, because it has to do with this conference actually, where maybe one of the first one or two conferences, John presented a paper and I asked him some questions, and that led to a different paper that we worked on with Shanthi and Sita Slavov. And then I was telling Damon about that paper, and that's what led to this paper. So in some ways, maybe it's like, I don't know, not a child, but a grandchild or something of this conference. So this is joint work with Damon and Shanthi Ramnath, who's at the US Treasury. And it has benefited from generous support from the TIA Institute and also the Social Security Administration. So there are a lot of different types of retirement wealth that people may rely on. And one dimension that they differ on is how much liquidity they offer to the holders of that wealth. And so you can think of a range of fully liquid sources of retirement wealth, so something like a checking account, to some sources of retirement wealth which are completely illiquid until a certain point in time, so something like Social Security wealth. And then there's also instruments in between where they have some partial liquidity. So for instance, individual retirement accounts or defined contribution accounts. And in those types of accounts, the level of liquidity is determined by any penalty that exists on early withdrawals, the age threshold where the penalty is lifted, and any exceptions to the penalty that are granted. And the optimal mix of these types of saving vehicles, or the extent to which policymakers subsidize one over the other, is an important question to consider. And it also has implications both for consumption and labor supply decisions after the assets are available and fully liquid, and also as people anticipate reaching those ages at which point they become liquid. So what we do in this paper is we're going to focus on individual retirement accounts and on one specific retirement savings vehicle. This is a big, important source of retirement wealth for many people. There are about $7.8 trillion invested in IRAs. And these receive preferential tax treatment, but also have some limited liquidity associated with them. And in particular, IRA withdrawals are subject to a 10% penalty if they are made before age 59 and a half. But there are certain exceptions that allow you to access these accounts. Those exceptions are made based on either death or disability of the primary account holder, unreimbursed medical expenses, health insurance premiums that are paid during unemployment, and there are a few other exceptions as well. Okay, so what are the kind of the implications of those different, of basically the liquidity in these accounts? So we think it could affect three different things. One is it could affect just the level of withdrawals that you take prior to retirement. This is known in the industry as leakage. So leakage represents the amount that comes out of those accounts before someone reaches retirement. And it's been estimated, I know John Sablehouse has a paper on this and with some co-authors, and they estimate that approximately 40 cents of every dollar that's contributed leaves these accounts prior to someone turning age 55. It also influences the ability of people to smooth consumption over time. So if you can't access the wealth in these accounts and you have a negative shock, you may have less ability to sort of address those shocks with the wealth that you would have in these accounts. It also may change the attractiveness of whether you put money into those accounts in the first place. So if you're putting money into an account where you have no liquidity associated with it until a particular age, you may put less of your wealth inside those accounts. So there's a trade-off between both this goal of consumption smoothing and the goal of retirement wealth accumulation, which makes this an important area to study for policy. The other thing I want to add is that there's been some recent work by John Bashirs, James Choi, Hurwitz, Leibson, and Madrian, where they compare the liquidity across 6 developed countries. And they, all but the US, are overwhelmingly illiquid until someone turns 55. So the US is somewhat of an outlier with respect to different countries. So what do we do in this paper? We're going to ask the question of how withdrawal behavior changes as individuals cross the age 59 and a half threshold. And what we're going to do is we're going to employ the use of data from administrative tax records. And we're going to leverage differences in date of birth because, as I'll describe more, the data that we have access to is aggregated at the annual level. So we only see withdrawals made over particular calendar years. And so we're going to use this variation in date of birth to try to understand the patterns of distributions and how those vary across this age threshold. And we're also going to be able to look at some sources of heterogeneity across different types of people and see how this heterogeneity affects how much people withdraw from their accounts when they're first eligible. So just to give a quick preview of our findings, we find evidence of a sharp increase in daily average withdrawals at age 59 and a half. How big are these increases? It amounts to about $1,600 a year on average. This includes amounts, this is not conditional on taking a withdrawal, so it includes people who don't make any withdrawals as well, and it represents an 80% increase from pre-59 and a half levels. We see higher increases at age 59 and a half for the low income quartile, and we also look across different shocks that people experience prior to turning age 59 and a half, and it looks like people with disability shocks can insure those shocks more easily using funds from these accounts than people who are unemployed prior to turning 59 and a half. And this is not surprising as I'll go forward based on how the exceptions are designed. So there is a related literature. I mentioned some of the work already. There's also a small literature about required minimum distribution. So this is how you have to take certain required distributions when you turn 70 and a half from these accounts. But we're not going to be looking at those at all. We're just concentrating in this paper on what happens at age 59 and a half. Okay, so the data we have access to is the universe of IRS tax and information returns, and we also link that to Social Security Administration data on date of birth, and we use data from forms 1040, W-2, 1099-R, 5498, and 5329. We collapse the data, and I'll illustrate more about our identification strategy in a minute, but we're going to collapse our data into birth year by year cells, birth date by year cells. And for the years that we observe, we include people who are between the ages of 57 and a half and 61 and a half. And we also limit our sample to those who had a positive fair market value in their IRA at age 57 and a half. And this amounts to about 1/3 of the population. Okay, so this shows you just a little bit about the summary statistics from our data. You can see it's a relatively high income group. The mean adjusted gross income at age 57 and a half is $134,000. And the next two rows under that show the share of people in the calendar year in which they turn the age that's on the column header, what share of those individuals take an IRA distribution. So in the calendar year in which someone turns 57 and a half, about 7% take a distribution, and this increases to 13% in the calendar year someone turns 59 and a half, and then it increases to 16% in the year after. The conditional distribution amount is the average distribution amount for those who take distributions, and that remains relatively constant over the period that we study. Okay, so let me try and illustrate our identification strategy with a series of figures. So suppose, as in this figure, the pattern of withdrawals follows a linear pattern that just increases over time, and there's no break at age 59 and a half. And what we're illustrating here is the withdrawal patterns for someone who turns 58 and a half relatively early in the calendar year, okay? So this person is relatively old in the sense that they have a longer amount of time in the year that they're exposed to no penalty in that calendar year. Okay, so as I mentioned, what we observe in the tax data is aggregated amounts of what they withdraw in each calendar year. And so that corresponds to the shaded regions in this figure. And if we were to just look at the change between what was withdrawn in the calendar year someone turned 58 and a half, and compare that to the amount withdrawn in the calendar year they turned 59 and a half, you would see that the difference is basically that pink shaded area. And that represents the incremental distribution in calendar year 2 relative to calendar year 1. Now, if you instead look at a person who turns 58 and a half later in the year, okay, and you do the same exercise, you will basically get the same amount. That's the incremental increase from calendar year 1 to calendar year 2, okay? Now let's change the pattern of withdrawals to one where we see evidence of a break at 59 and a half, and then do the same exercise. When we now look at the incremental increase, you can see that the shaded pink area represents the amount that distributions would increase by in calendar year 2 for the older individual. But if I do that same distinction for the younger individual, you can see that that increase is smaller. So now if I compare what I see for the older person relative to the younger person, I would expect to see a bigger change in calendar year 2 for the person who was exposed to more time where they didn't pay a penalty. Okay, so that's essentially what I'm going to show you here. So what this figure shows is basically annual distributions on the y-axis, and and what we're plotting is basically the distributions in the calendar year that they turn the age that you see on the x-axis. And this first line represents people who have 1 to 3 months of penalty-free withdrawal in the year that they turn 59 and a half. So these are people who turn 59 and a half in either October, November, or December. And you can see that it increases each year, but the increase is relatively small in between 58 and a half and 59 and a half, and bigger from 59 and a half to 60 and a half. Now, if I then show you the same data for those who have 4 to 6 months of penalty-free withdrawal, you can see that the pattern is smoother. And the same thing happens, so you see the kind of the same phenomenon going on if I show you additional groups of people. So you see the steepest increases in the year that someone turns 59 and a half for those who had a longer period of time that they were exposed to no penalty, okay? And the same thing is basically true if I, instead of looking at quarters of birth, I look at months of birth, okay? So this is essentially the results just kind of in a figure. But these results do rely on some strong functional form assumptions. And so what we then do is we relax those functional form assumptions and fit different degree polynomials to the number of days before and after someone turns 59 and a half. And also we vary the level of aggregation that we use in the data. And so just to illustrate that, so here the y-axis is the daily distributions, and the y-axis is event time relative to when someone turns 59 and a half. And this is using a linear approximation on either side of this cutoff, but the slopes can vary. And the increase at age 59 and a half is estimated to be around $4 per day, and I'll come back to that number and give you a sense of magnitude. If we do a cubic approximation, I get a slightly different figure, and a quintic approximation, I get this figure here. But when I look at basically the estimate of the jump from the day before you turn 59 and a half to the day after, that estimate ranges from about $4 per day to about $9 per day. Okay, and this is equivalent, the 431 in the fourth column on the top row is basically equivalent to $1,573 annually. and it represents an 80% increase above the annual withdrawal in the calendar year someone turns 58 and a half. So going forward, I'm going to show you some heterogeneity, and I'm going to focus on the third order polynomial and the daily level of aggregation. Okay, so this is basically the heterogeneity across different sources of potential negative shocks. So what we show you here, let me just walk you through this figure. First, the first set of bars represents the full sample results, so that 613 is replicated right here. And then these three other groups represent people who received UI at 57.5, disability insurance at 57.5, or those who were itemizing their medical expenditures at 57.5. And what you see here is basically the level of distributions right before someone turns 59.5 and the level of distributions right after. And so the difference between the two represents the jump. And then the shaded area on each of the green graphs represents the share of the pre-59.5 withdrawals that were subject to a penalty. Okay, so there are a few different observations we make from this figure. One is that the increase at 59.5 is highest for those who received unemployment insurance at 57.5. So this is much higher than the baseline result we get for the full sample. And the share of withdrawals that were subject to a penalty are also much higher for those who experience an unemployment shock. Whereas if we look at the DI group, they spend a much smaller proportion of their withdrawals before 59.5 were subject to a penalty, and their increase was not larger as it was in the UI case. Okay? So this suggests that under the assumption that the demand for withdrawals were higher for those with negative shocks, that you might infer that the DI recipients were better able to insure against this risk than the UI recipients. And it kind of makes sense when you think about the penalty exception, because those who are disabled basically receive kind of a blanket exception to withdrawals from these accounts, whereas those who experience an unemployment shock only receive an exception for amounts that are used to pay health insurance. Okay? So the next cut I'll show you is just heterogeneity across income quartiles. So this is across quartiles of adjusted gross income. And what you see here is that the amount of pre-59.5 withdrawals that were subject to a penalty is pretty constant across the income distribution. And the increase at 59.5 is smaller as you go up the income distribution. And so it could mean that the lower income quartiles were more constrained by the penalty. But I'll mention some other thoughts, and I know Alex will as well, about how we might think about interpreting these results in a minute. So just some other heterogeneity that we looked at is that we didn't find any significant differences in the increase for people who turn 59.5 in recession years or those who are taking the mortgage interest deduction. We also we try to decompose this into the extensive margin and the intensive margin, and our results suggest that a large share of the response is due to increases in the likelihood of taking withdrawals rather than the amount withdrawn conditional on taking a withdrawal. But this result is sensitive to functional form assumptions. We do a series of placebo checks where we look for the same kind of discontinuity at 58.5 or 60.5. And across the board, these coefficient estimates are economically small and generally statistically insignificant. Okay, so the summary is just that, we find evidence of an increase. This increase is fairly large, and we find some interesting heterogeneity. Where we're going with this next is to try to estimate some kind of benchmark model so that we can better understand these patterns and also try to simulate what those patterns would look like in this benchmark model for different types of agents, and to get a better sense of kind of what the mechanisms are that are underlying these results. So that's all I have, and I'll pass it on to Alex.
Thank you to John for the opportunity to discuss this paper. It's a pleasure to read the paper and a pleasure also to discuss the paper of Gopi, who helped to host me here at Stanford over the past year, and Damon, who's my co-author, and Shanthi, who's my former colleague at the Treasury Department. So I'm glad to be able to comment on on their work. Yes. Okay. So just in summary, as Gopi has just told you, this paper estimates how IRA distributions respond to the removal of the 10% early withdrawal penalty at age 59 and a half. It develops and applies a method, building on some previous methods, for using data aggregated at a lower frequency, in other words, an annual frequency, to estimate effects at a higher frequency, up to a daily frequency. They find an increase of about $1,600 in annual withdrawals upon reaching age 59 and a half, driven by the extensive margin, and explores heterogeneity. So before I turn to my comments, I just want to make a comment on the comments, which is I discussed this paper about a year ago, right here over in another room at Stanford. And the good news is that the authors have responded to the comments. That's great to see. And I had suggested looking at a model with a liquid and an illiquid asset, and that is work in progress. The bad news is that I'm going to as the discussant, my job is to make their life more difficult. So I'm going to add on additional complications and additional kind of twists to some of that advice, and of course in the hope of being useful. Okay, so my overall assessment is this is a good paper. It has credible results. It has a nice methodology section on the annual versus the daily results. I would love to understand the economics and the welfare implications better. I think a key issue is sort of what are the welfare effects of these early withdrawal penalties, and I'd love to kind of push these results to understand what they mean and how to understand that welfare question to the extent that we can. And I know that the authors are actively developing that model, and so that's good. And so what I will say now is more about offering thoughts than giving answers about what that model will show. Ultimately, the author's model may address all of these thoughts, but I want to maybe preview some of my thoughts on what the model will show, and then talk about some complications in potentially understanding what the results mean. So I want to think about the results in the context of a simple economic framework. The paper focuses on estimating the discontinuous increase in withdrawals from just prior to age 59 and a half to just after age 59 and a half. Intratemporal substitution can play a role in determining that jump, and I think that has important implications for how we think about what that means. So what does that discontinuous jump tell us about economic parameters? And in turn, I'd love at some future stage to understand what does that tell us about whether early withdrawal penalties are good, what ages they should be imposed at, until, and so forth. So there's a discontinuous change in the penalty for withdrawing assets from illiquid accounts and no change for liquid assets. So what does that create? It creates a sort of discontinuity in the penalty at age 59. And this is an example of what Joel Slemrod has called a time notch. There's sort of a notch in time. This is sort of a notch at an age, a specific age, and there's a notch in the budget set. In other words, you might delay the withdrawal or the consumption associated with that drawal to avoid the early withdrawal penalty, and it should induce so-called bunching and withdrawals above age 59 and a half, bunching being the density of withdrawals should be higher right above age 59 and a half than right below age 59 and a half, and there should be sort of a hole in withdrawals right before age 59 and a half corresponding to the people who moved to after age 59 and a half. And that difference between the hole to the left of age 59 and a half and the bunching to the right of age 59 and a half, that vertical distance is sort of what the authors are effectively estimating, and so I want to think about sort of what that means a little bit. In contrast to some notches, before we get into the notch discussion, I just want to note, in contrast to some notches, in this case, with some notches there's a dominated region because, if you, let's say, earn $1 less, then you're subject to a discontinuously smaller average tax rate or something like that. Ages just below 59 and a half are not necessarily dominated ages in this context if people have truly immediate consumption needs. So it's different than certain contexts in which notches have been explored recently in the public finance literature, in particular this Clevin and Wassim paper, which estimates sort of methods for estimating responses to a notch. There's a dominated region, and that's not quite true here, but in any case, I want to go through sort of the theory of notches when there is a dominated region in it, and it applies more or less to what the authors are doing. So with a notch in the budget set, in other words, a discontinuous change in the level of consumption from one, in this case, age to another when you withdraw from the IRA, with a notch in the budget set, there should be bunching just below the notch, and then there should be this sort of missing mass, and just on the other side of the threshold. In this case, it would be the 59.5 threshold. So what you get is so relative to some sort of smooth counterfactual density. In this case, it would be some smooth counterfactual density of ages at which people would realize withdrawals in the absence of the notch in the budget set. You should get some bunching on one side of the threshold, and that bunching should be equal to the missing mass on the other side of the threshold. So there's this missing mass of people who move to the other side of the threshold to get on the more economically favorable side of the threshold, and that the size of that missing mass should be equal to the magnitude of that bunching. So now let's think about sort of what that discontinuous jump means and how it relates to the bunching. The bunching is related to but different than the discontinuous jump. So in particular, the discontinuous jump, the immediate discontinuity, sort of measures the difference between this sort of suppressed level of density on this side and the elevated level on this side. And so the immediate discontinuity is this vertical distance. The bunching, which is the response, that is something that, first of all, is just on the y-axis, it's just this vertical distance, and on the x-axis, it has, it's basically integrating under this curve and above this curve. So the bunching that is the response, in some sense, or the response from which an elasticity can be estimated, is sort of different in two ways than this discontinuity. One is that it's only this part of the y-axis as opposed to this larger discontinuity, which reflects the missing mass here as well. And also, it's sort of an integral of summing up some people underneath the bunching curve. So you could certainly use the author's methods to estimate that bunching, because there were some nice pictures in which I'll show you later. So there's this clear, sort of bunching that they find. So it's certainly possible to use the author's methods to estimate that. So what can you do with that? You can use that amount of bunching, which represents, how many people are responding, essentially, to estimate. In principle, you could estimate the intertemporal elasticity of withdrawals with respect to the penalty. And the amount of bunching basically may be able to tell you something about the welfare implications of this penalty. So in particular, here's how I thought about it. The amount of bunching tells you how individuals trade off the need for immediate cash. So there's some people realizing just before age 59 and a half who need immediate cash against the tax or penalty considerations that in their lifetime income is lower if they realize before age 59 and a half relative to after age 59 and a half. And so it can give you a sort of distribution of a bound on how much the bunchers act as if they're willing to accept to delay the realizations. So in particular for the excess mass of realizations just after 59 and a half, for the bunchers, they are willing to accept an increase in lifetime consumption associated with avoiding the penalty to delay realizations. And so that's an upper bound, that gives you an upper bound on their minimum willingness to accept to delay consumption until after 59 and a half. Under age 59 and a half, what you could do is use the distribution of missing mass across realization ages relative to 59 and a half to trace out the fraction of the population willing to accept a consumption increase to delay realizations for different amounts of time. So in other words, you have these people who really, really need, who are just to the right of the threshold, or who are just over the threshold, who are realizing just before age 59 and a half, they really, really need the cash immediately. These people who are just to the right of them, or who are just, who are realizing just before that, they need the cash a little bit less, and so forth, all the way back until you get back to essentially the counterfactual density. And so you can trace out the distribution of how people trade off essentially that immediate need for cash against their lifetime consumption, or their consumption in the future. And people who realize, just before 59 and a half and pay the penalty must value that immediate cash more than the 10% penalty, or it's possible that some of them are inert, or they're inattentive to the policy. And that distribution of willingness to accept values is related to the welfare consequences of the penalty. So that's sort of how I think about it. Now let's sort of take that to the data and think about how we might apply that to the data. So we do see the bunching. We don't see missing mass. So that's kind of a puzzle. There's a slight puzzle that there's actually a little bit of an uptick right before 59 and a half. And I would have expected there to be very few people who were said to be realizing before age 59 and a half. It's very slight, so I don't want to, rake the authors over the coals for something that's really a blip. But I would suggest, but I do think this is significant in at least two senses. So first of all, I think it's worth investigating the robustness of that uptick, and I think it might be an artifact of how they're doing the polynomials. So in particular, they show linear polynomials, cubic polynomials. This is from the 5th degree polynomial. All of those are odd-numbered polynomials. And with an odd-numbered polynomial, one feature of it is that if you think about its y value, it either has to go from negative infinity to infinity, or from infinity to negative infinity, one way or the other. So in this case, because withdrawals are increasing with age, the odd-numbered polynomial sort of has to go from negative infinity to infinity. And so as an artifact of that, you may be kind of smoothing over the missing mass. And so I would suggest trying to use other sort of rich functional forms to see whether you can figure out how big that missing mass is, and then once you figure out how big that missing mass is, then that helps you in estimating the degree of bunching. So my conjecture is that with a sufficiently rich sort of functional form, this would show that there's substantial missing mass just below the threshold, and that would allow you, in principle, to estimate that distribution of willingness to accept and so forth, and try to get at some of the welfare implications. So having said all that, I also want to comment further that there might be some complications in understanding this economics. So one complication is that at the same time as there's an early withdrawal penalty for IRAs, there's also an early withdrawal penalty for 401ks. And that lasts until 59 and a half for most people. There are some exceptions, just like with IRAs, but for most people it lasts until 59 and a half. And so in terms of the modeling, I think you don't want to just think about one illiquid asset. There's sort of both IRA illiquid assets and non-IRA illiquid assets. And it's not clear to me what will drive the choice of whether to withdraw from an IRA or a 401k, but there is another discontinuity in time which is perfectly collinear with this. And so I think you want to think a little bit about that, and it could also affect your modeling strategy in terms of just thinking about the illiquid versus the liquid. It's actually, there are two kinds of illiquid assets. You're observing one of them. It's not possible to observe 401k withdrawals in the data, so it may be a little challenging to get a handle on this, but I think that's one complication. A second is that it might be difficult to separate sort of people who have truly immediate consumption needs and who are realizing right before age 59 and a half from people who are just inert, who are just unaware of the policy, aren't thinking about this, and so forth. And so when you think about applying a method for estimating bunching or estimating elasticities from bunching, like in the Clevin and Wassim, they give you a way of estimating the inert share, but in this case, it might be hard to distinguish those inert people from people who just really need the cash today. And so you might need further information, like about the distribution of sort of liquidity shocks among liquidity constrained people. And so I'd encourage you to think about that a little as well. Final complication is that focal points, I think, are also really important in retirement behavior. So for example, the normal retirement age has been shown to be sort of a focal point for people in considering when to claim Social Security, and to some extent in their retirement behavior, lesser extent in their retirement behavior. Maybe 59 and a half is just sort of a focal point for when people withdraw, or just after 59 and a half. And so in that case, there might be some distinction between people's true preferences and their true willingness to accept if they were sort of not subject to to just thinking in these crude ways about focal points versus what actually drives their behavior. So that's sort of a further complication in understanding the economics. So with all that said, I think this is a nice paper. It's credible, it's promising. Despite all of those caveats for interpretation, I think to the extent possible, it would be fascinating to use these patterns to better understand the economics and ideally the welfare implications of early withdrawal penalties. The authors are actively doing this. I look forward to seeing the results. They may, I'm sure they are developing great answers to a lot of those questions. Ultimately, I think these are really interesting results, and I just love to understand a little bit better what they mean. So that's the direction I would go in. Yeah, thank you.